We're actually going to be working on worksheet 10 today, which is on section 9.4. But first, we're going to start with this little warm-up, which is the back of worksheet 9B, side 9B. Does that sound right? Okay, 15 through 17 are just 3 multiple choice questions on the concepts we covered yesterday. Switching from polar coordinates to rectangular, rectangular to polar, and equations of those. But I need to know what the 4 important things you are supposed to have memorized about the relationships between those are. They're the same 4 things from vectors. X is equal to? Good job. Y is equal to? Okay. But if you have an X and a Y, how do you find R? If you have an X and a Y, how do you find R? Yep, Pythagorean theorem basically, yes. And how do you find the angle? Okay, those are the 4 things that are probably not on a reference sheet that you need to know. Everybody good with those? Okay. So, what is question number 15 giving us, and what is it asking for? When it wants polars, what form does it want? R theta. Okay. Rectangular means it's telling us what? An X and a Y. So if we were to sketch this, we'd have -3, -3. We'd be down here somewhere. We need to know the R and the theta. Ideas, guys? Pythagorean theorem. So -3 squared is 9. 9 plus 9 is 18. Square root of 18 would be 3 square roots of 2. That's our radius. Okay, if we went over 3 and down 3, what angle is that in there? You can do inverse tangent, but it wants an answer in radians, and it's going to give you an ugly decimal. And that's not one of the choices. Okay? If it's 3 and 3, it's a 45, 45, 90, yes? So we need 45 degrees into the 3rd quadrant. Look at the choices. It is pi over 4, but it's into that quadrant, so it's 5 pi over 4. Everybody good? Because we figured out that it was 3 square roots of 2, so it was either H or F, and H is the one that puts us into the proper quadrant. It's pretty easy when we did process of elimination. All right, what is number 16 giving us already? An R theta, and it's asking us to find what? An X and a Y. Okay, got to watch the vocabulary. All right, so if we went around 150 degrees and out exactly 4, how do we find the X and the Y? What are we going to do, though, about the fact that these are not decimals? Nope. These are degrees. Use your unit circle. What is the cosine of 150? Negative square root of 3 over 2. So if you take 4 times negative square root of 3 divided by 2, You get negative 2 square roots of 3. Right? What's the sine of 150? 4 times a half would be 2. So which coordinates are we looking at? Good job. Everybody okay? Unit circle and r cosine theta, r sine theta. All right? This is one that you could use your calculator for. What should this graph as? A circle. Unfortunately, several of these are circles. We could complete the square to figure out where the center should be. But are there some traits that are pretty darn easy? X squared plus y squared is? And 5y, what can y be replaced with? And then what? Divide out an r. So we get choice J for just right, Faisal, when he said that about 5 minutes ago, right? Everybody okay? Kind of review what we did yesterday? All right. Then I want to switch over to today's worksheet 10. We're not going to do all of these examples because I'm hoping to have some time for some homework questions, all right? Deal? Because this is really pretty easy. It sounds really complicated, and there's parts of it that I'm not really comfortable with the concepts. But what you have to do for the questions are super easy because you get to use the blue reference sheet. And on the back is a chart that tells us everything we need to know. Do you see this chart that says polar equations of conics? I will hereby solemnly swear that I will not ask you about one of these unless I let you use that chart, okay? This is not stuff you need to know the rest of your life and have memorized. With the exception of this concept, not that it's important for the rest of your life, but you are supposed to have already memorized those ideas. Do you remember that? Eccentricity of a parabola is 1 because there's only one focus and one vertex. Okay? The eccentricity definition, again, is the distance to the focus divided by the distance to the vertex. From the center here, there's C, and this would be A. So when we put C over A, we get less than 1. Now, here's a new concept. Did you know an ellipse had a directrix? Okay, not so much, right? It is a line outside of the ellipse. It can't go through the ellipse, okay? That's all we're going to worry about today. A parabola, we do know where the directrix is, yes? It's outside the parabola and the parabola opens away from it. A hyperbola, remember from the center, the distance to the vertex is A, the distance to the focus is C, so when we put C over A, we get something bigger than 1. All right? The directrix for a hyperbola runs in between the two branches and in the same way that, that makes sense, right? In between the two branches. That's good enough. It never cross. Okay, we'll just go with that. All right. All of these really crazy formulas right here will give us a conic when we graph them in polar form. What are the conics again, guys? 4 of them that we studied. Circle, parabola, ellipse, and hyperbola, okay? All of these would give us a conic. Now the question becomes, what is the eccentricity? Do you remember what eccentricity even meant? From like a circle to an ellipse, remember the eccentricity made it stretch more? Kind of remember that? The closer to 1, when we move those two foci, when we're doing the string thing on the board, remember? The further apart we move the foci. Okay, the closer we got to one, it became more oblong, right? All right. So today, what you need to notice, and you're going to get to use the chart, so you don't have to memorize this, but the ones with cosine have directrix that's x equals, okay? The ones with sine have directrix that's y equals. It says in the directions that E and D are always positive. So if there's a minus here, the E is still considered positive. The minus came with the equation. And then this is a negative D back here when there's a minus in there. Down here, the same. When you have a 1 minus E sine theta, it's y equals negative. All right. Really important. Hope you're paying attention. This number has to be what? 1. If it's not a 1, we have to do something to make it a 1. Because only when it is a 1 is the eccentricity the number here. What am I talking about? Okay. Here's an example. You know what? I'm actually going to skip this one. I'm going to start with one that you guys have to do so you don't fall asleep. Does this one have a 1 where we want there to be a 1? Yes. So this matches an equation that looks like ED over 1 minus E sine theta off the sheet, yes? And for that equation, it says the directrix, I'm sorry, for that, yeah, for this polar equation, it says the directrix will be at y equals negative D, is that right? Okay. We need to figure out what the eccentricity is, what kind of conic it would be, and the equation of the directrix. If it already has a 1 here, we know the eccentricity. It's just this number right here, so the eccentricity is 1/2. You can graph it on your calculator, but what is an eccentricity of 1/2 going to graph as? Ellipse. Very good. Then we need to figure out what D is. Anybody have any ideas how to figure out what D is? E times D is the numerator, which is 2. You just told me E is 1/2, so when I plug that in, I have 1/2 of D equals 2. To get rid of 1/2, you multiply over there, and you get D is 4. Multiply by the 2. Multiply by A2 on both sides, however you want to think about it. D is 4, so what is the equation of the directrix? Y equals negative 4. You cannot just tell me D is 4. You have to give me the equation of that directrix, okay? Let's graph it. Two divided by, I'm in polar mode, and radians with a 2 pi setting on there. 1 minus 0.5 sine theta in the denominator with parentheses around it. Sam, did you have a pass?
Yeah.
Okay, did you put it out there? Thank you so much. All right, guys, we did get an ellipse. The equation we came up with was y equals negative 4. What kind of line is that? Show me with your hand. Y equals negative 4. Okay, so it's down here 1, 2, 3, 4. Does that seem okay? Remember I said it had to be outside the ellipse? Was good, right? Y equals negative 4 worked. And we said it was an ellipse. Let's try number 2 real quick. This one goes fast because does it already have a 1 out there? So the eccentricity is 3, which makes it a hyperbola. And the top is E times D equals 3. Well, guess what? If E is already 3, then D is 1. So what's the equation of the directrix? Y equals 1. That's it. And you just look it up on the chart. All right. If we graph it real fast. Now when it graphs these, it connects every point as you go. That's an issue because it ends up drawing in drawing. Yeah, that's what I want to say. It ends up looking like you have drawn the asymptotes. If I could finish my sentence. Really hard to see, but do you see that in here was a hyperbola and down here was a hyperbola? And it's even harder to see, but the line y equals 1 would go in between them. Not necessarily through the exact middle. It's not through the vertex, but it would go in there. Does that seem okay? I don't have a very good window for that graph, but I'm just going to keep going. All right, what changes? Something changes a lot. Yeah. We have to get rid of the 2 and make it a 1. Guys, quick, pay attention here. To change this 2 to a 1, we're going to divide everything by 2 on the top and the bottom. Basically, we're multiplying a 1/2 onto the top and a 1/2 onto the bottom, which is a form of 1, right? Multiplying the top by half, bottom by half. So get why that's legal? I'm multiplying by this, which is just multiplying by 1, yes? Say that again. Yeah, I know. If the 1/2 was in the denominator, if you had like 2 divided by 1/2, then it would become 4. I know what you're saying. Yeah, I get what you're trying to say, but we're just multiplying. So half of 4 is going to make the top a 2. Half of 2 will be 1. Half of 3 will be 3/2. And that's multiplied by a sine theta, and we just multiplied it. We distributed the 1/2 through there. Better explanation? We understand why it works now, why it's okay? So we have, what is the eccentricity? E is 3/2. There's one of the 3 things we're supposed to come up with. 3/2 is, be careful, for some reason the other class couldn't figure out whether that was more than 1 or less than 1. It's more than 1, so it is a hyperbola. The numerator is 2, which is E times D. And D was 3/2, so we have 2 equals 3. I'm sorry, E was 3/2. Did I say that backwards? I think I did. D was 3/2, so E was 3/2. We're looking for D. I'll just keep saying it backwards. Yes, we need to multiply by 2/3 to both sides so that this will just leave D. So we get 4/3 equals D. It is a 1 minus sign. So we look on the chart. Everybody know what I'm talking about here? 1 minus sign says right here, the directrix is y equals the opposite of D. Okay? So the directrix is y equals negative 4/3. All right, anybody graph this one? I'm going to graph the original one just to make sure we didn't make a mistake. 2 minus 3 sine theta. We said it should be a hyperbola. Mine look like a hyperbola. Negative 4/3 would be just a little below negative 1 here and going horizontally. Now it does cross it. Remember, it just has to be in between the loops of the hyperbola. We don't care where. We're not going to go there. All right, how about you pick one of these? We don't need to do all of these, do we? Number 6? Okay, what do we need to do to everything here? Divide by 3 or take 1/3. So 9 divided by 3 will be 3 on the top. 3 divided by 3 will be 1. 6 divided by 3 will be 2. So the eccentricity is 2, which is a hyperbola. The numerator is E times D. But if E is already 2, then D is what? 3/2. So the equation of the directrix, X or Y, positive or negative? If I have them memorized, yes, what did it? For D, yes. You don't get the same eccentricity. But because you're taking something and dividing by something that we didn't simplify, it's going to come out the same. Does that make sense now? You won't get the right answer for E, but you would get the same answer for D, yes. Okay. Should we graph this one? Or are you going to trust me? You don't trust me? Okay. We can come back and do 4 and 5 tomorrow as warm-up if you want. Let's look at the back real quick, though. The back is going the other direction. But this is not complicated. Look, if they give us E and they give us D with an equation, do you know right now all kinds of things? If you know E and you know D and you know it's X equals a positive D, you can write the equation. That's it. That's why I decided to do this section, because I thought it would be easy points, yes? On the quiz? As long as you have a chart. Okay, E is 1. What's D? D is 1.5. X equals a positive 1.5 means the equation should look like X equals a positive 1.5. So it should be R equals ED over 1 plus E cosine theta. What did we say? R equals ED 1 plus E cosine theta. Okay. So put some numbers in there for me. What's the top become when you do E times D? 1.5. What does the bottom become when you put in E? 1 plus 1 cosine theta. Okay? E is 1, so it is a what shape? It's a parabola. I am never going to take your calculator away from you, but I believe it's going to open, because its cosine is going to open sideways. So we're going to type in what we just wrote for an equation. 1.5 divided by 1 plus cosine theta. I'm not going to be super picky, but can you kind of tell anything about it? It opens to the side. Looks like the vertex is at 1, doesn't it? Here. It almost looks like it crosses between 1 and 2 up this way. Oh, is it 0.75, so it's not quite 1? Yeah. If you do a trace? Okay. As long as you have it opening roughly the right way, and I'm good. All right. Couple quick ones, and then we'll do some questions. Number 8, E is 3. So what should this graph as in a minute when I go to graph it? Hyperbola, okay? What is D? D is actually positive 3, because D is always positive, but the negative tells us that the equation is going to be what? 1 minus, and the fact that it's Y means sine. Yep. Oops, I forgot the E out there. There should be E. You don't have to have it memorized, okay? What are we going to do? E times D on the top becomes 9. On the bottom, 1 minus E sine theta becomes 1 minus 3 sine theta. And we're supposed to graph it. We said it should be a hyperbola. Okay, and like we said earlier, it had y equals -3. Would that go in between these two branches down here if we graphed that? Okay, can you tell where it's crossing? A little below 2? Somewhere around 5? I don't know. I don't care. Does that look good enough? I'm not going to be picky. You don't even have to have the asymptotes in there. As long as you got some little curvies here in the right quadrant, the right area, I'm good. Should we be done? Okay. We'll do some more practice on this tomorrow, but this is really a very easy, straightforward assignment as long as you can use that chart. What can